In this video, I'm going to walk you through running a de novo assembly of E. coli mate pair data from Ion Torrent. The first step is to launch seqman-nggen, and when you do that, you'll see a welcome screen like this. I'm going to keep the selection of Create New Assembly Project and click Next. Here I'm asked to choose my project type, which is genome assembly, so I'll keep that and click Next. And then I need to choose my assembly type, which is de novo. So I'll select that, click Next. Here I need to give my project a name, and I also need to choose a project folder for my output files. So I'll go ahead and select that. Then I'll click Next to enter my reads. And first I need to select my read technology, so I'll choose Ion Torrent. And I'm going to be adding both single end as well as mate pair reads. So I'm going to add the single end from the top section here. And I'll add the mate pair from the bottom section. And here it's asking me to enter an insert size. And the insert size is the expected distance between the pairs. And I'm going to enter 10,000 for that. Click OK. And when I click Next, I'll see the read options as well as the assembly options. And these pages allow me to adjust the parameters that are used for the assembly. However, these are already optimized for me based on my earlier selection, so it's specifically for an Ion Torrent de novo assembly. So the only thing I need to do here is enter the expected genome length, which for E. coli is 4.6 million. Then I'll click Next, and that's all I need to do to set up the project. The final step is to click Assemble, and that will begin the assembly. Once the assembly is finished, you can open it in seqman Pro for analysis. And you can see here in the project window all of the contigs that were created during the assembly. So the next step typically for a de novo assembly is to order your contigs and group them into scaffolds. And I'm going to do that by clicking on Unlocated Contigs so that they're all selected, and then go to Project, Order Contigs. And what this will do is utilize the mate pair data to group them into scaffolds. And here you can see that seqman Pro created several scaffolds, and I can expand them by clicking on the triangle next to the scaffold name to see the contigs within each one. I'm going to double click on one of these scaffolds to open it in the strategy view. And here you can see the position of each contig at the top of the window and the individual reads that make up each contig down in the bottom section of the view. One of the things that the strategy view allows us to do is to take a closer look at the gaps between contigs. And the best way to do that is to use this arrow button here, which allows me to choose which type of mate pair data to display in the bottom section. Choosing the blue arrows here will show me only the mate pair reads that are located in different contigs. So I'm going to choose that. And I'm also going to click this button here, which will remove the sequence names in the bottom section just so that I can get a more condensed view. And now I'm going to zoom in a bit here, right around position 409,000, where there's a gap between contigs 251 and 281. And you can see right away that there are a lot of blue arrows in that section. And these are all representing pairs where one of the reads is in contig 251 and the other is in contig 281. And that information just supports the ordering that seqman used for the contigs within the scaffold. So the next step would be to close these gaps. And there's a menu command that will close some of them automatically. And to use that, I would return to the project window, make sure my scaffold is selected, and then go to Config, Align Contigs and Scaffold End to End. Once the contig alignment is finished, you'll see at the bottom of your report window details on which gaps seqman Pro was able to close on its own. And you can see here that contigs 281 and 251 were merged together. So if I return to the strategy view for scaffold 180, and then go back to the position where we were before, right around 409,000, you can see that the gap is now gone. Now, gaps that were not closed automatically will require a few more steps, and I'll cover manual gap closure in a separate video. If you have further questions about doing an ion torrent assembly in CMan, or any other questions about our software, please visit our website at DNASTAR.com or contact us at support@DNASTAR.com.